So friends, welcome to our channel Electrical Decodes. In this video, we are going to see about the basic requirement and specification of the capacitor bank. In the previous video, we discussed about how to calculate the capacitor bank ratings with a detailed explanation. So in this video, two things we are going to discover. And if one thing is the general requirements for the capacitor bank and the specification as per the SEWA regulation. So we'll start with the general requirement. Capacitor bank main purpose is to maintain the power factor in the system. So it should be maintain the power factor in the range of 0.95 lagging or the unity. This is the first requirement of the capacitor bank. And the second point, big machines ESC and big size motors on the different lights we have. So this will affect the power factor. So these machines and AC and discharge lights like this deviation should be incorporated with the power factor correction. So in third point, any project with a transformer or total connected load above 80 kilowatt shall be equipped with a capacitor bank. Okay. In your project, for example, it's a small project. So you have a total connected load of 70 kilowatts, for example. So that project, no need to incorporate and no need to add capacitor bank in the system. So in case if your project have a transformer or the total connected load of your project is more than 80 kilowatts, then install one capacitor bank parallel to your supply. Fourth point, all the power factor correction capacitors shall be tri-type and metal encapsulated and sealed type. So it's a normal, all the capacitor bank always coming with the tri-type, not always. What we are using for our purpose, always coming with the tri-type and metal encapsulated with the sealed type. Next point, the discharge on disconnection circuit will be permanently or automatically connected to the capacitors. Okay. So once you install the capacitors, there is one thing we will install that is called discharge resistors. So this what will happen once your power went off, that time it will de-energize your capacitors and it will take all the energy from your capacitors gradually. So this should be automatically done in your capacitor itself. So it cannot be a manual discharge method. So normally in the small size capacitor bank, small size capacitor, what we will do here for the fans and the small size capacitors, we will discharge with touching each. If positive and negative will touch, there is some spark will come, it will be discharged. But in case of big and large size capacitors, we should be install one discharge disconnection circuit in the capacitor itself permanently, and it automatically the powers off from the capacitors. And this should not be manual discharge method. So this is the main requirement of the capacitor bank. So another one, all the capacitor bank components are suitable for the system voltage and ambient temperature of the local circumstance. It's a normal thing because it's as per an UAE condition, normally the ambient temperature is more as compared to our normal India or any Pakistan or other countries. So based on the local circumstance, all the components what we are using in the capacitor bank like MCCB, fuse and discharge resistors, these are the things it should be capable to work in the system voltage and the ambient temperature also. The capacitor bank shall not be a part of LV panel or MCC or SMDB, and it should be a separate cubicle. Okay. So in this point, we are going to see one schematic for the next slide. So I once again read this one. Capacitor bank shall not be a part of LV panel or MCC or SMDB. Okay. It's capacitor bank is a separate cubicle, means separate panel. So as I told here, see for example, this is a LV panel. What we see here, this total is LV panel. Here income is coming. This all outgoing. It's going okay. So what in the point mentioned here, it should not be attached with this LV panel. Okay, so here we give separate panel for the capacitor bank. This will connect the cable to here and it will feed the reactive power to the system. So the capacitor bank must be a separate cubicle. It's not merged with our LV panel or any MCCB related. So these are the basic things of the requirement of capacitor bank. The second thing we'll go for the specification. All the components shall be capable to continuous work in the full load current and voltage. Okay. What are the things we are going to incorporate in the capacitor bank. First thing we will add is a disconnecting switch. After that, we will add some conductors, relays, and fuses. Then it will go to the capacitors and detuned reactors. So these are the more things we will added in the capacitor banks. These are the components should be continuously work in the full load current and full rated voltage without failure. So these are the first specification is the system should work at any case. Yani, full load, full current continuously available for 24 hours, it should work. The second, if any malfunction happen under the continuous deviation of voltage plus or minus 10% or plus or minus 5%, it should work. In the system, anything happen, any switching device or anything, something happened in the system, there is a deviation in the voltage plus or minus 10%, still your capacitor bank has to be work. So this point meaning that one only. All the components are capable to withstand the dielectric stress which is created from the short circuit current. In case of any short circuit happen in our circuit, it should be withstand that high rating of current, short circuit current also. Another thing, capacitor unit shall be ambient temperature rated. It's we already discussed in the previous slide itself. There is a built-in discharge resistor shall be placed on the safe discharge of capacitor after switch off. So this one I discussed in the previous slide. There is some discharge resistor to discharge the capacitor and after its switch off. So it should be placed in the capacitor. It should be discharge the capacitors automatically, not manual method. And the final one, the capacitor should not be restart a minimum of 3 minutes after restoration of the supply. Due to some any error issue and the power went off, total LV panel is shut off. After 1 hour, you rectified the errors and after you clear the mistakes, then you are going to restart the LV panel. Okay. If you restart 1 o'clock, your capacitor bank should be start at 1.11 after 3 minutes later only. So this is the major thing to avoid any of the damages in the circuits. And the final things, in the capacitor bank, we have a permanent nameplate. And the nameplate mentions here who the manufacturer of the company and what is the serial number of the capacitor bank and rated voltage and frequency of the capacitor bank, which is it can be worked. And discharge device details, as I told you, and this resistor or some other types, and short circuit current rating, if how much short circuit current it can withstand, and the rated reactive power. Rated reactive power means minimum things should be available in the permanent nameplate of the capacitor bank. I hope this video will give you the more details about the specification and requirement of the capacitor bank as per the SEWA standard. Subscribe for more videos. Thank you.